Part 2, the nuclear atom. All right, what you're looking at here is an animation of the atom. Now, it's not to scale. The nucleus here, if this was the size of the atom, the nucleus would be so small you wouldn't be able to see it. This is called the electron cloud, the region of space where we would find an electron. We'll be talking about that in much more detail later on in the unit. But for now, notice that the protons and the neutrons both make up the nucleus. They are the nucleus, and the electrons are outside the nucleus. Okay, now, during these notes, I'm going to need to refer to a periodic table. Now, this is the periodic table hopefully you picked up from Tigard High. If you haven't, it's there in the reception office. You can just drop by anytime that they're open and pick one up. Strongly encourage you to do that. It's a nice, sturdy periodic table. But if nothing else, you can print it out. If you go to our Canvas site, on the side here, there's a link for the periodic table. That's the exact same periodic table that I'm showing you here. It's important that it's that periodic table because the numbers, what's called the atomic mass that has decimal places, we want to all use a periodic table that has the same exact number of decimal places. Some periodic tables only have one decimal place, some have 5 decimal places. We want to use ones that have the exact same numbers. Also, depending upon when the periodic table was published and who the publisher was, the numbers could be slightly different. Surprisingly, they can change a little bit over time. So anyways, use this periodic table. Okay, now if you don't have it right now, you're going to find the homework that I'll be asking you to do a little bit more difficult, but of course you can use the one online. But I think you'll soon realize having a hard copy is the way to go. All right. Subatomic particles, the constituents of an atom. Now, hopefully you've already taken the pre-notes and are prepared to just fill in what I'm going to be giving you here. If you didn't do the pre-notes already, please stop, do that, and then come back. Okay, now first, these are the headings. So let me just go ahead and jump into the proton so the headings have more relevance. The particle, first, there's 3 subatomic particles. The first is the proton. The symbol that we use for it is a lowercase p. Now, it's very important in chemistry that we use the correct symbols. Uppercase and lowercase in science can be a game changer. So you can't just use capital or lowercase because you like that. There's a very specific way that we use letters and numbers to represent things. So proton, lowercase p. And where is the proton? It's inside the nucleus, as I showed you a minute ago. Now, relative charge, relative mass. Let me explain what we mean by relative. It's one thing compared to another. So say that you were 16 years old and I was 64. Well, then I would be 4 times older than you. So we could say whatever your age is, you could say it in minutes or days or months or years. I would be 4 times that. So one thing compared to another is what we mean by relative. So the relative charge of a proton is a positive 1. Of course, you might say, well, relative to what? Well, hang on to that question. Relative mass is approximately 1, not exactly. And again, I'll kind of clarify that in a minute. The actual mass is 1.673 times 10 to the negative 24. So that's 24 decimal place and 24, well, actually 23 zeros. So really, really, really small number. Next, the neutron. The neutron has a symbol lowercase n. It also is inside the nucleus, as you saw. Now, collectively, protons and neutrons are referred to as nucleons. So a nucleon is either a proton or a neutron. It's the particles that make up the nucleus. Now, the neutron has a relative charge of 0 and the relative mass of almost exactly the same as the mass of a proton. But if you look at the actual mass, it's a little bit more, 1.675 times 10 to the negative 24. So really small, but it's ever so slightly more massive than a proton. Now, why these are not exactly 1, you'll need to wait until a little later in the unit when we talk about atomic mass and relative mass. That'll make more sense then. than the electron. The electron, we use a lowercase e, but for the electron, we include a negative sign on it. Now, sometimes for protons, you'll see a positive sign, and for neutrons, you'll see a little zero. But we don't use that, but you'll see that occasionally. But we do, and pretty much universally, we use a negative sign on the electron. So the electron without the E, without the negative sign, or E without the negative sign is not an electron. It would have another meaning. The electron is far outside the nucleus, as you saw in that animation. Now, its relative mass is really, really small. You would need to have 1,840 electrons to have the mass of a proton or a neutron. So it's really, really small, yet its charge is a full -1. And what we say when we compare such things, a proton is a +1 and an electron is a -1. So we would say that they're equal in magnitude, but opposite in sign. So even though the electron is so much smaller, it has the same magnitude of charge, just a different sign. The actual mass of a electron is 9.11 times 10 to the -28. So 4 more zeros there, really small. Okay, now the periodic table, we'll have an entire unit. Our next unit is the periodic table. So why the periodic table is arranged the way it is, why we have some rows with nothing there, we will explain. Why are these 2 rows removed? All of that will be explained in our next unit. We are only interested for our current purposes, the numbers that we find in each one of the boxes of the elements. So this here, they're using hydrogen as an example of each of the numbers that we find in the box. This is the little key for that. So let me blow that up. So hydrogen is the element. The atomic number is 1. The atomic number is the number of protons, as you'll see. Symbol is capital H, and the atomic mass is 1.01. The state of matter, the little balloon there, means it's a gas. Note, an element symbol is written using block letters. So don't use cursive letters if you use cursive. Block letters. And if it's just one letter, it's a capital letter. But if it has 2 letters, the second letter is lowercase. An example is gold. The symbol for gold is capital A, lowercase u, and that's gold. Now, anytime that you have a name of an element that's different than the English name, it's because the original name of that element or the symbol comes from another language, usually Latin or Greek. Symbolic notation. Chemists use specific notation to indicate the number of subatomic particles in an electron. And so that's going to be our focus here for the rest of our time, is how many electrons, protons, and neutrons does an atom have, and how do we represent that? So example, so this is bromine. This bromine is right here on the periodic table. Okay. Notice that you have a 35 here. That stands for 35 protons. So that's written down here. Okay. The numbers that are written above are called superscripts, and the number that's written below is called a subscript. Now, when you write superscripts and subscripts, you need to do just that. So I know some of you don't have the best handwriting in the world, but for symbolic notation, such things are really, really important. So superscript, you can see it's written above the bromine, the capital B here, upper left, and the subscript lower left, upper right. So a good way to remember superscripts like Supergirl flies high and submarines go low. So subscript is the number written below, superscripts, they're written above. Okay, so let's use this as our generic representation of an element and the symbols that we, where we place symbols and what the meaning is. Okay, so this is the chemical symbol from the periodic table. And so again, in the periodic table, you'll have the symbols for each one of the elements. This is aluminum, this is boron, carbon, nitrogen, oxygen. The atomic number is given the generic symbol Z, and it stands for the number of protons. Now, on the periodic table, it's arranged by atomic number. So if we start in the upper left, atomic number 1 is hydrogen. Atomic number 2, way over here, is helium. And then atomic number 3 is lithium, beryllium, etc. So it goes by row, just ever increasing, 1 proton more, 1 proton more. That's what defines an element, how many protons it has. Oxygen has 8 protons. If an element doesn't have 8 protons, it's not oxygen. An element that has 14 protons is silicon. Only silicon has 14 protons. If silicon was to lose a proton, it would be aluminum. That's what defines an element, is the number of protons, and we call that the atomic number. And that's written in our symbolic notation here as a subscript in the lower left. Okay, now the number above is called the mass number. Now the mass number is the total number of protons and neutrons. So we add the two together. Or another way of saying it is the total nucleons. Now, if you wanted to know the number of neutrons, you would have to subtract the number of protons from the mass number. There is no number that tells you the number of neutrons directly. You have to do a little bit of arithmetic there. So the number of protons would be the mass number, this number here, minus the atomic number. Now, this is called the charge. Now, it's a question mark because it could be no charge at all, or a positive charge, or a negative charge. And we can always know what the charge would be by comparing protons and electrons. If we have the exact same number of protons and electrons, the charge would be 0. It would have no charge at all, in which case we wouldn't write anything. But if we have more protons than electrons, then this would be a positive charge. If we had more electrons than protons, this would be a negative charge. Now, if we wanted to know how many electrons we had, we would take the atomic number, which is the number of protons, and subtract from that the charge. And we'll do this in a few minutes. No, I guess we'll do it right now. Okay, so we're going to do some practice here. So this is helium. This is the symbol that we're given, and we're asked, well, how many protons, neutrons, and electrons do we have? Well, remember that this is the atomic number, which is the number of protons. The atomic number, the number of protons, is exactly the same thing. The mass number is the total number of protons and neutrons. So the number of neutrons is not 4. We have to subtract the number of protons. So the mass number minus the atomic number, 4 minus 2 is 2. So we have 2 neutrons. So 2 neutrons plus 2 protons gives us a mass number of 4. Now the number of electrons, because it has no charge, must be the same as the number of protons. So remember, the atomic number minus the charge tells us the number of electrons. So 2, the number of protons, minus no charge, would mean we have 2 electrons. So the simple way of looking at it is that if it has no charge, it has the same number of electrons and protons. Okay, let's do another. Okay, so now this one has a charge on it. Okay, so we want to know the number of protons, neutrons, and electrons. So remember, this is the number of protons, the atomic number. Okay, let me backtrack here a little bit. So that means we're going to have 12 protons. But yes, what I was showing you here is when we write the charge, we don't write the sign before the number. We write it afterwards. Now, I'll have to ask you to hold off on exactly why we do that until you take a higher level chemistry class. It deals with not confusing what's called oxidation number with ionic charge. This is the way we write ionic charge. If it was an oxidation number, we would write the sign before it. So just accept this is the way that we write it. The sign is written after the number. Right, now the number of protons is the atomic number. That's this here, so that's 12. And the number of neutrons, remember, is the total number of protons and neutrons. And so since the mass number is 24. Subtracting 12 from 24 gives us 12 neutrons. Now the number of electrons, because we don't have a neutral charge, it has a positive charge. So it must mean we have 2 more protons than electrons, because electrons are negatively charged. But remember, we can easily calculate the number of electrons by subtracting the charge from the atomic number. And the atomic number is 12. Subtracting 2 gives us 10. Now that's really a harder way to do it. Simply, when you're asked how many electrons you have, just look at the number. Say, well, I have 12 protons, and I know protons are a positive 2 charge. A positive 1 charge. For the ion to have a positive 2 charge, it must mean I have 2 more protons than electrons. And so, in other words, we have 10 electrons. Okay, now we're going in the opposite direction. We're given the number of protons, neutrons, and electrons and asked to write the symbol. Now for this is where we have to have a periodic table to know what the symbol is. Protons here, we have 17 protons, so we need to go to our periodic table and find atomic number 17, which is right here. Now remember that the elements are arranged according to atomic number, just increases going across, and so here's 13, 14, 15, 16, 17. So 17 is the atomic number for chlorine. So Cl would be our symbol that we would write. So chlorine. And then we would write the atomic number, which is the number of protons, as a subscript on the left. And then for the atomic mass, for the mass number, we would add the number of protons and neutrons together. Okay. And then since we have 1 more electron than protons, it must have a -1 charge. Okay, let me recap this in case I lost any of you. The 35 here is the total number of protons and neutrons. So 17 plus 18 gives us 35. That's the mass number, the number of nucleons. This is the atomic number, which is exactly the same as the number of protons. And because we have 1 more electron than protons, and electrons are negatively charged, it would mean that we would have a -1 charge. If we had, let's say we had 19 electrons, then this would be a -2. If we had 16 electrons, then this would be a +1. We would have more protons than electrons. Okay, so I suggest pausing the video and see if you can do this yourself. And I will do it in 3, 2, 1. All right, so 82 protons. So we need to find the element that has 82. 82 is its atomic number. Okay, so now the periodic table have ever-increasing atomic numbers as we go across, so 1 through 2, 3 through 10, 11 through 18, on and on and on. And I've forgotten the number 82 is lead. Now, pay no attention to the numbers that have decimal places. That's something that we're not talking about at all now. We're talking about the whole number that's written right above the symbol. So 82, that is lead. So Pb will be the symbol that we'll use. Okay, so atomic number is 82. And then for the total number of nucleons, the mass number, we need to add 82 plus 128 to give us our mass number. So 82 plus 128 gives us 210. So the mass number is 210. Now, because we have 4 more protons than electrons, we have a +4 charge. Remember, in a previous slide, the charge is going to be the number of protons minus the number of electrons. So 82 minus 78. Okay, before I conclude here, let me show you something that's pretty cool. Now you have a homework assignment. Now the homework assignment we're going to do to some extent tomorrow in class, though some of you might be able to finish it tonight, though it's not due until Tuesday. Remember, Monday's a holiday. Okay, now this is the assignment here, chemical symbols. If you were to click on that, this is the assignment. Now, this will be the first time that you're going to be taking a picture and submitting a homework assignment. So hopefully you already copied this down. Now it needs to be done in your notebook. So you can't print this out and fill it out, I'm sorry. But you don't need a ruler and make a fancy table. This is just an easy way to present the material. You could just use the lines on your paper, maybe skip a line in between each one, and maybe use a ruler to draw the vertical lines to separate the columns. Make sure that you label the headings here, as it says. Include all information given. So it's kind of like a puzzle. You're given a certain bits of information and you're going to be asked to fill in the missing pieces. Now, to help you with this, Ms. Wall has a terrific tutorial. And it's right above the assignment. So this is the assignment, chemical symbols, and right above it is a tutorial. Now the tutorial is for this very assignment. So let me show it to you. So if you were to click on that, take you here. Now this uploads into Canvas, but let's watch it on YouTube. And get bigger. Now she walks you through the very assignment that you have. So if you're stuck, this is going to be a tutorial video. Big help. About writing chemical symbols. So I'll let you watch it for a minute. The element symbols and what all of these numbers mean that are around the symbol, how we get those, and what information it tells us. So this is from. Okay, so she's going to review what you had just taken, but let me show you when we get to the actual worksheet. She's going to start showing you how we do it.
Works is it's super fun. It's like a puzzle. So you're given some pieces of information for each of these elements, and you're only given just enough where you can figure out the rest. So if you think you're stuck, if you think you aren't given enough information, kind of try to look at the problem a different way, because in fact you are given enough information. Sometimes you just have to think a little bit outside the box. Okay, so this first one, we have Si, which is silicon. And then it gives us this top left number, which we know is the mass number. Okay, so this 28 is the mass number. So right away, and you can do this in any order you want, but I know that that 28 is the mass number, so I can actually go here and write that down for myself so that I remember that I know that the mass number is 28. Okay, and so, you know, since you're new to chemistry, you might feel like, well, I don't know what else to do now. That's all I know. I know that the mass number has the number of protons and neutrons, but I don't know either one of them, right? But you do know, because we learned in class, if you use your periodic table, if you find silicon, which is underneath carbon here, it has an atomic number of 14, so Si 14. That 14 is its atomic number, it's its chemical identity. So I can put 14 here, but what that also tells me is that we also have 14 protons, because I know that the atomic number is equal to the number of protons. Okay? The number of protons gives you the identity of an element. So these two columns here, atomic number and number of protons, those are always going to be the same going all.
Okay, so just wanted to show you that she's going to do a really nice job of walking you through the first few rows here. So please watch the video if you're having any problems at all. Now some of you will pick up on this really quickly, some of you not so much. So please take advantage of this tutorial. Now tomorrow in class, we'll be doing some practice too. So don't fret if you need some help. All right, but for right now, that is it. That is the end of notes. All right, I will see you soon.